Bonjour, je m'appelle Kevin. I'm from Google, and you've now heard about all of my French. So unfortunately, I will be giving the talk in English. Hopefully, I'll be able to speak slow enough that people will be able to understand. There will be time for questions after the talk, so please be ready with those. This is obviously, it's a very sophisticated audience. You're familiar with data-driven uses, data science, doing big data analytics, and coming into machine learning. Machine learning is taking over now because there are problems in our society, in computing, that either can't be done at scale or cannot be done at all. And having this data-driven machine learning allows us to address both of those issues. A simple example is being able to recognize simple things like a cat versus a dog. This is something that any 2-year-old can do with almost 100% accuracy. But even a decade ago, it was impossible for computers to do that. The old method of writing procedures and trying to figure out exactly what is a cat or a dog. It has 4 legs, it has a nose, it has a tail. Dogs have different kinds of ears that are floppy, different kinds of colors. As we started moving into this more data-driven type of computer modeling, we started seeing success 4 or 5 years ago in being able to do some simple recognition. And as we've gone further and further, now there are machine learning algorithms that are better than human radiologists, for instance, at recognizing tumors in medical imaging issues. To make it even more clear, distinguishing between a cat and a dog seems like something that we should be able to do pretty easily. But what about distinguishing between a dog and a muffin? This seems really trivial, right? I mean, a dog has a nose and eyes and ears and 4 legs and fur. A muffin is round, has a dome top. But when you get into the edge cases of this, you start realizing that there are examples there, no matter what kind of rules you try to program, you're never going to achieve the success necessary to be able to handle cases like this. And the real world is messy. The signal-to-noise ratio isn't always as good as we want. And so as you start looking at real-world images, you run into cases like this that simply cannot be solved. No programmer will ever be able to write down the procedures to be able to distinguish these scary images. So right now there are a lot of obvious examples where machine learning is being applied. Self-driving cars, being able to recognize roads, recognize intent, recognize people, recognize that if you have a trash can on the side of the road, you can drive by its speed, but if there's a person there, you have to recognize that and take different actions. Recognize road signs. Communication. We now have the ability to, using machine learning again, to take audio, break it down into the semantic meaning, and then translate that in real time into other languages. So the universal translator is coming. I'll be able to speak in English, and you'll be able to understand me in French. We actually have this capability today, but it doesn't scale completely well for an audience like this. Playing games. I'm sure many of you followed or heard about the success of AlphaGo in taking on world champions in one of the toughest games known to man. We beat the Google AlphaGo program beat the European champion a couple of years ago, and then went on to beat the world champion, 18-time world champion Lee Sedol, about a year ago. And since then, the original AlphaGo program was trained by entering data from top Go games. So it was a classic example of taking good examples and training it to be successful. About a year ago now, there's a new version of AlphaGo called AlphaGo Zero. AlphaGo Zero was trained entirely from scratch. It was only given the most basic rules of the game and then set off to play itself back and forth. In 3 hours of training, AlphaGo Zero beat the version of AlphaGo that beat the European champion 3 years ago. After 21 days of training, it beat the version of AlphaGo Master, that we call that now, that beat the world champion. Today, it continues to go on, and it has rediscovered all of the strategies that humans have used throughout history to play the game, and found that a lot of them are very, very good. It also found some new strategies that had not been determined by humans before. So this is very exciting stuff. And a game is an interesting example, but when you look about how this can be applied to solve real-world problems, you start seeing the potential of where this is all going to go. So Google has a set of APIs that are available to anybody for translation, for vision, for doing video analysis, for doing audio transcription. And we're going to go through some of those examples, and I'm going to show you some real-time versions. So the Vision API is a simple REST API. I'll have a couple little code snippets for you too. It's able to recognize objects. It will tell you a location of where something is. It will turn any text into text, optical character recognition. For companies that want to check for intellectual property violations, you can run images through and find misuses of your images, misuses of your logos. And it can even help you crop images to make them better. So here's a simple example. This is a sign in the Google office in New York City, where there are several different elements of text there. When you pass this through the Vision API, you get all of this text broken out into logical semantic steps that you can then analyze. So it gives you all the text and all the different sections. So we have some example we'll show you later that makes this more real. It can recognize objects. This is obviously a very, very familiar object, especially here in Paris. It's the Eiffel Tower. But this also shows you some other things up here. So this mid, and by the way, all this data you get back from the REST API in JSON. So you can parse this and drop it into a database and query it and do anything else you want. So this mid here is an identifier for the Google Knowledge Graph. So Google, over now more than a decade, has built up what we call the Knowledge Graph that relates semantic entities together. So we have knowledge about an object, not just an individual thing. This also gives you a bounding box for what part of the image it used to recognize that particular thing. And in this case, because it is a physical object, it gives you the location in latitude and longitude of where you're going to find that thing. It can do things that aren't incredibly well known. This is an image of a car. It happens to be a Ford Anglia. It happens to know that this is a car that's at a museum. So it tells you where the museum is. It recognizes that it is a Ford Anglia, but more importantly, this specific car is interesting because it was the Ford Anglia used in the Harry Potter movie series. So it's able to tell you this, and again, with the entity IDs and the MIDs, gives you relationships of all those objects and how they relate to the world. So here's what it looks like when you get the raw data back. And we have the APIs available in 7 what we call Google Silver languages: Node.js, Python, Go, Java. Pretty much anything you're going to be using, you can access these APIs. So let's go ahead and take a look at a demo here. So this is a public web page at cloud.google.com/vision. You can go there and give this a try yourself. So there's a simple example where you can just drag and drop a file into this, and it then tells you about this. So this is another interesting object. It's again the Eiffel Tower, but this isn't quite the real Eiffel Tower. So Google is able to distinguish that this is the model of the Eiffel Tower in Las Vegas. So it's able to distinguish this. It shows the bounding box here, as this is the portion of the image that allowed me to recognize this object, and it found this thing underneath here. There is not a gigantic building underneath the main arches of the Eiffel Tower. So it says that that one happens to be in Las Vegas. So I find that very interesting. So as you go through this, you can get all the tags, all the labels that says this is a tourist attraction. It's in a city, it's a steeple. So if you take your images and you upload this, you can then query on all of this to be able to find images relating to what you're doing. In this case, it also points out where you can find this image on the web. So it shows a Wikipedia entry for this particular object. And again, if you're doing for a company, checking for logos, for instance, this will tell you all the places where your logo might be being misused. And it tells you whether the object is safe for work. So you make sure you can do detection for pornography or other adult subjects. And again, all of this is available. It gets dropped into JSON, which you can then parse and bring into any database that you like and query it in any way that you want to. So let's go back to the slides. So the Vision API is great for general purpose subjects, but it's not great if you have custom data, domain-specific data that is interesting for your business. So last year, Google introduced a new tool called AutoML, and it is a completely data-driven way of building machine learning data models. So there's a simple web page. I'm going to walk you through that in a minute, but as an example, let's say that I'm a meteorologist, and I want to be able to predict the weather. I might work for an airline. I work for an event management company. I want to be able to figure out what the weather's going to be like on the day of my event or for this upcoming flight. And I figure out that there are 10 different types of clouds, and they give us some example of what is going to be happening with the weather. So the question is, can we use the cloud to analyze clouds? And if we use the standard Vision API like we demonstrated earlier, it will tell you that yes, it's a cloud, it's sky, but it won't tell you anything about anything deeper about that. So with AutoML, you take data, you upload it, you tag it, you build the model, and then you can make predictions of additional images. So let's go ahead and take a look at that. So again, right now this is in an early access program. This is available, but there's only a few hundred customers currently using it. We are expanding capacity to make it more generally available. So in this example, you start out at the import, and if you have your data, your images already up on Google Cloud Storage, you can access them directly from there. You can upload the files directly. You build a simple CSV file with the links to the data. You upload that, and then the system will go through and import all those images. After you do that, you then go through and you label the data. So we collected about 1,500 images. We just put out a call inside Google, please send us your cloud images. And we uploaded all of those. And it turns out that Google has a meteorologist on staff. And my first response was, but then it becomes, the meteorologist is part of the Google Loon project. So there actually is a real value that for Google Loon is the big balloons that stay over areas to provide internet access. And right now they're deployed in Puerto Rico and some other places providing internet access after natural disasters. So we had this meteorologist go through and tag all of these different images. Say about 1,500. You then run the training model. There's two different models you can do. There's a simple one and a more advanced one. And then you can evaluate this data. It shows you confidence curves, false positives and false negatives, so you can decide whether you have enough data yet to make the kind of predictions with the accuracy that you expect. And it will also show you confusion matrix that says which parts are really good and which parts aren't as good. So for instance, in our data, we have like 500 images of cumulus clouds, the big fluffy white clouds that are very common, and fewer of cirrus and cumulonimbus that cumulonimbus do thunderstorms. So we see that there isn't as much confidence in cirrostratus, for instance. After you do that, you can then make predictions. And in this case, we put together a simple Firebase application that this runs on a mobile phone as well. And I can upload a picture of a cloud, and it will, right now this is running on a couple different small VMs, so it takes a couple seconds to power up. But here we see that this first image I have is a cumulus, and it says this is a big fluffy cloud that's going to make nice weather. It's a nice warm day. So let me try another one. And in this case, it's a cumulonimbus cloud. It also gives confidence. So it says here that it's only 71% confident that it has this correct. But it says this is an indicator of thunderstorms. So be aware of upcoming weather. So let me go back to the slides again. So this is a fun example showing this with clouds, but we're working with customers that are applying this in manufacturing and other types of domains. So looking automatic inventory tracking, checking for part quality. You can imagine taking images of a rack, for instance, and you can be able to tell whether you need to reorder parts. You can checking for part quality. Parts going by on an assembly line, making sure that those things are all working well. And there are many, many other domains where this is going to be interesting to apply. Now, the video intelligence does a similar type of thing to the vision API, but applies it to video. So not only does it do the things that the vision API does, being able to recognize objects, do OCR, it also does that scene by scene automatically. So it breaks the entire video up into individual segments that allow you to then do queries against that data and jump right to it. So let's go to that demo. So this is just a simple video that's been uploaded. As soon as I start this,
Tumble area just outside Pittsburgh. My name's Scott Baker. My family has been connected with this community for generations.
This video is running, but you notice underneath here, I'm going to pause this, there are all these tags, and there are segments on there showing where those things are. So for instance, a carriage. What is that going to be?
I started thinking, baking is in my blood. It's what we do.
There is a carriage at that location. So for companies that have any type of large video library, this allows you to bring that library alive. You can now query on any individual object, any words, anything you can see in that, and jump then directly to that location, a map. It jumps right there. And you see multiple segments. Here is a track.
We're just coming up the ramp.
So for companies like Netflix and YouTube, these are obvious examples where you could allow people to do much better querying to get to the things that they're looking for. But also think about if you do video blogs or video support in your company, now people can find the information relevant to them very quickly and jump directly to the spot where they're going to get the answer that they're looking for.
It was my life,
Next one is translation. We talked about at the beginning the fact that you can now, the machine learning speech recognition algorithms have gotten good enough to be able to understand my language, convert it into a semantic setting, and convert that then into the language of someone else. So again, this is a simple REST API. Here's an example of a little code snippet in Python. And a nice thing about this is you don't need to even tell it the language that you're presenting. So you can take any text, upload it using the translation API, and then just tell it the target language that you want back. You want this back in Japanese, and it then returns the text in the language that you want. So for any person, any customer around the world, wherever they happen to be, all of your data can be converted into useful information for them. And speech. So this is speech to text. I've got another fun example here on this one. So you can extract all the text from a video and does all the timestamping. It timestamps each individual word, so it gives you the full text of the presentation and allows you to jump to any point within that. So let's go to one here. So this is Urs, one of the early employees of Google. He runs the technical infrastructure at Google. And
last year, we committed
the
to
audio.
continuously drive down costs for our customers in alignment with Moore's Law. And since then, we announced 3 major price reductions.
You have audio, please,
And we
from the
continue to
computer.
lead the industry in combining strong performance with low cost, as well as flexible, commitment-free pricing options. We believe Google Cloud Platform delivers better performance at lower cost.
So you see all the text
than
down
other
here,
cloud
but
providers.
I can
You
go
may
ahead
wonder
and
how we're
jump
able to lower your costs by as much as 70% compared to standard
directly
VMs.
to
And they're perfect for
anything.
adding. For example, you may start off on a standard VM, but as you grow, a new class of machine may result in dramatic savings. The flexibility to change regions or classes of machines to meet your changing business needs with no penalty.
So again, if you have this large video library, you can run the videos through this and make all of that text searchable, allow you to go directly to any portion of that. Natural language, this breaks things down, and it can actually understand context within phrases. So for instance, in doing sentiment analysis, a simple example, the food was terrible. I will not go back. It says that this on a score from -1 to 1 that this is a negative review, and it's pretty confident about this. But a more sophisticated example that's more like what you find in the real world, there might be some subtlety to this. So I like the sushi, but the service was terrible. The natural language it understands these 2 different phrases and can rate them separately. So this is an example where, in all your social channels, all your support channels, there can be a lot of noise to figure out where to dedicate time to address customer problems. This can be a very effective tool for doing that. And content classification. So we have large publishers. Anybody who collects lots of information, especially from third parties, you can run all of that information up through this and get back that, in this case, that it's a recipe. It's about food. And you can then use that to categorize and drop it into the correct section of the website or make it available to the people interested in any particular topic. So that is all I have to talk about today. These are links to all of those, all the demos. You can go try all those yourself and play with the vision, play with the audio, play with the speech recognition, etc. And with that, I am happy to take any questions. We have a few minutes left. Okay, I guess my English was really good.
Just a question about the pricing of this kind of services. Mm-hmm. Do you pay on a per request prediction?
Yes. So all of the demos, all of the links up there, there is a free tier for every single one of those to go try, so you can go play with it for free. After that, it's like, the prices are all up there. It's like 15 cents per 100,000 or something like that. So you can decide how to scale the access to it.
And about training, it's the same thing as Cloud ML basics in ML units and stuff.
I'm sorry, I missed that.
For the training of the AutoML algorithm you showed, it's the same stuff as the Cloud ML training. It's based on ML units.
Correct. Yeah. So ultimately you're paying for the compute time for doing either the training and the prediction. And if you're doing AutoML, there'll be storage cost associated with your specific images as well.
Thank you.
Sure. Other questions? There's one over here.
Hi. Regarding data property, do I have the guarantee that everything that I upload for training is not going to be used by Google?
Absolutely.
In any way? Okay.
All of this is covered by the Google Cloud Terms of Service. You own the data. We don't look at it. We don't do anything with it. It is absolutely 100% yours.
Okay.
And that's good. I get that question every time, so thank you. There's one behind you.
Hi, thank you for your presentation.
Of course.
How does it handle in videos when you have multiple voices talking in the same time?
Google just announced a new capability where it's able to separate out two people speaking at the same time. This is just being rolled out now on the video API. So it will actually be able to separate out the words of the two speakers. And there's a very impressive demo we just saw at I/O where there are two people talking over each other, and Google can click on and off one speaker so you only hear the words of one side. So that's going to keep getting better. So the answer is that is not in the API, it is not in the recognition today, but it is coming. So the words would be jumbled if there were lots of speakers. But it will get better soon.
Thank you.
Thank you for the presentation. I have a question about the model for the meteorologist. You try to recognize the different clouds, and is a totally new model trained only with your data, or is it like are you using transfer learning that?
It runs on top of the standard vision recognition model.
Okay.
So it builds on top of that. So it's,
okay.
Yeah.
Okay, thank you.
Yeah. And for AutoML right now, it's strictly vision, but there is AutoML coming for other domains as well, translation, for instance. So being able to add specific business jargon, for instance. Every business has its own set of unique language, and people want to be able to recognize that. So in support call, for instance, you're talking about your products. Google doesn't know about your products. You know about your products. So okay. These things are coming too.
Okay, and just how many instances do you think are needed to have a model with good performance?
I'm sorry,
how many instances for training do you need?
You need at least 10 images of each label that you want. More is better. So like in this example, we had about 500 cumulus images, as few as 10 or 12 cirrostratus. And the prediction quality was lower, obviously, for the examples with less data. So, but you can do it with as few as 10 images for a label.
Okay, thank you.
You're welcome. There's a couple more behind you.
You've talked about the pricing of the API. You said about 50 cents per tens of thousands of requests. If I take, for example, the OCR, what if we want to apply it to short videos? Wouldn't it become more expensive?
There's, the cost is broken down into two pieces. There's the training cost of building the model, and then the prediction cost. So if you have 1 million short videos versus 1,000 longer videos, it might work out a little bit differently, but the prediction time is likely going to be constant.
Oh, all right.
But you should experiment with this. And you can use cost controls as well. So you can say, I don't want to spend more than $100 or $1,000 a month on this particular use, and it will throttle as it gets there. So you won't get any magic bills that are scary.
Okay, thanks.
There's one more in back, and we'll come back.
Hi. You said AutoML is reserved to a few clients. When will it be available kind of for all companies?
It's starting to scale now. I don't know the answer specifically, but I know that we've added significant new capacity in the last few weeks, and I expect to see that more rolling out over the course of this year.
And I had a second quick question on AutoML. You talked about a simpler and a more elaborate model. Can you detail kind of what's behind?
Yeah, I mean, though the trick of AutoML is being able to take a look at different types of data and decide what the best data model is to be able to yield good predictions. So it just does a more elaborate tracking. It looks at multiple versions additional and decides what's going to be best for the more elaborate model. So it'll yield higher prediction quality. There was another question. Oh, you got one there? Yeah.
A question about the natural language. Do you know if the extraction of entities is as good in French as in English?
I believe so. It's high quality in all the popular languages. There's over 100 languages that are supported. We certainly have more data in English, so there might be a slightly higher prediction quality in English, but it's very, very good in French and German and Spanish. And
could we do the same process like AutoML with the extraction of entities? If I can get a training set with some entities and text.
For visual today,
only visual, yeah.
For translation and recognition of text, that's coming later.
Okay, thank you.
Yeah. There was a question down here in front.
Yes, regarding OCR, a few years back, Google used reCAPTCHA to have the general public work. I think it was one of the most mind-blowing ideas that was ever done in IT. Would you say that now OCR is mature enough, so there is no more need for this? Because I didn't see that for a while. So now OCR is...
it's good enough.
Yeah. Okay,
yeah.
So
when Google moved over to the machine learning model, it understands, different font and character shapes, and it can handle, morphed text if it's, angled, and if there's obscure parts where the ink didn't flow correctly. So it's gotten remarkably good.
Handwritten language also, handwriting also is...
Handwriting is a little tougher, but it does pretty good.
Yeah.
So yeah, hand script can have more variability. So if humans are really bad at recognizing your handwriting, it might still be tough for Google too.
Thanks.
Here's one here in front.
Hello. So for analyze sentiment, like for the text, for the comments, you said that we can know if it's a negative review or a positive one. Can we do that in several languages? Which languages? And can we do more, like classify the comments by different categories?
Absolutely. So you'll get all the text, and you get the sentiment analysis as part of the JSON data that you get back from the natural language API, and you can do with that as you wish. And it works with over 100 languages.
Okay. Thank you.
You're welcome. Right behind you.
Thank you. Hi. I have two questions about your presentation. The first, I have one question, a little bit technical. I don't know the difference between the library Google Cloud and G-Cloud. There is some difference between the two libraries.
J-Cloud?
Yes.
I'm not familiar with that.
G-Cloud.
Oh,
G-Cloud.
So Google Cloud? G-Cloud?
And yes, Google.Cloud and G-Cloud.
I'm not familiar with any difference.
I found on the site of the Google, there is the two type of library when we work on Google Cloud storage, Google Cloud technology.
I'm not sure. Come talk to me afterwards, and we'll take a look.
Okay.
Okay.
Okay. And the second question is for machine learning, the programming language. I don't know all the functionalities on Python or Java or Scala. What language is perfect for?
There's 7 languages that are fully supported. So Node.js, Python, Go, Java, and I forget the other 2 off right now. But it's all up on the website as well.
All right. Okay.
C++.
Okay. Okay. Thank you.
You bet. And there's a question in
last
back.
question.
Yep.
A little question about your Google Translation API. You've shown an example of a pretty short text, but I was wondering if it could be scalable to large text or books without significant loss in quality.
It's super good today. One more minute, there we go. The translation capability today, we converted over to this machine learning translation a couple of years ago, and it works beautifully on long text as well.
Are there any languages that works better than others, or?
Probably. I mean, again, we have most of our data. We probably have more data in English than any, but for all popular languages, including Chinese, Japanese, Asian languages, we have sufficient data to yield pretty phenomenal quality.
All right. Thanks.
Yeah. Okay. Thanks very much.